Howdy, howdy. Mr. Thompson here with a video math lesson. Talking about volume. Okay, we are going to look at calculating the volume of prisms and cylinders. But before that, just a little word on the units involved for volume and converting between units in the metric system. So units for length were just units, units for area were square units, and units for volume are cubic units, okay, or units cubed. So we have all our normal players here with the metric system: kilometers, meters, centimeters, and millimeters, okay, but in this case they are all going to be cubed, right? Okay, kilometers cubed, meters cubed, centimeters cubed, millimeters cubed, all right, and we're going to convert between all of these, and we have all our normal sort of numbers, right, that we're used to, and all those numbers were squared for area, and so if you can follow the pattern here, those units will be cubed for volume. So converting between kilometers cubed and meters cubed, we multiply by 1,000 3 times, right? So you can move the decimal to the right 3 times, right? Move it 3 times, and then 3 more times, and then 3 more times, right? You do everything thrice, right? 100, move the decimal place twice, and you do that 3 times, right? Okay, and then of course converting this way, you move it to the left, or divide by 1,000 3 times, or divide by 100 3 times, and so on, right? Pretty simple. Well, I'm not going to go through an example because shouldn't be too tricky, but maybe I'll do another video with examples later, if you like. Now, with volume though, a lot of times things like liquids are measured in volume, or flour or stuff like that, and one way that particularly liquids are measured is with liters, okay? And with liters there's some other units as well. We have megaliters, kiloliters, liters, and milliliters, right? Megaliters, kiloliters, liters, and milliliters. Liters and milliliters you might be more familiar with. You know, large bottles of drinks are measured often in liters, 1 or 2 liters. Milk in liters, at least where the metric system is used. Milliliters are, you might see smaller canned or bottled drinks in milliliters. These ones are used more often for things like pools or huge tanks of gas or something like that. But we can convert between these, and it's pretty easy. Okay, going that way, we're going to multiply. Okay, going from the big one to the smaller one, right? And the nice thing about these is each one is 1,000. So from megaliters to kiloliters, multiply by 1,000. From kiloliters to liters, multiply by 1,000. And liters to milliliters, multiply by 1,000. So pretty easy to remember. And of course, going back the other way, we just divide by 1,000 each time, right? Now, these are 2 different ways to measure volume, but volume's the same thing. Volume is volume, right? So we should be able to convert from the meters and centimeters and so on cubed to liters and milliliters and so on, right? And we can. It's pretty easy. And there's a connection between centimeters cubed and milliliters. In fact, it's 1 to 1. 1 centimeter cubed equals 1 milliliter. So you can sort of use that as a point of reference. If you have something in these units, convert them to centimeters cubed. That's milliliters, and then you can put it back to one of these if you need to as well. Okay, or you can make your own little shortcuts from one to the other if you like, and make a table and have all kinds of fun. But anyway, okay, there's our units for volume. Let's talk about the volume of prisms and cylinders. Okay, now prisms and cylinders are very similar. They're basically a shape, right, such as a rectangle, extended through space to make a solid, right, or a triangle extended through space to make a solid, right, or you could think of it as a rectangle is kind of like a card, and this would be like a deck of cards, a whole bunch of cards lined up. You could think of that as a rectangular prism, or a bunch of circular, discs. A stack of CDs is like a cylinder, right? So you have a circle extended through space to make a cylinder, right? A 3-dimensional physical solid object. Now, the great thing about prisms and cylinders is you basically find the volume the exact same way for all of them. Okay, they all have the shape that they started with, that was kind of extended through space, as we say, and you can find the area of that shape, right? Area of a rectangle, area of a triangle, area of a circle, okay? And then all of them have sort of this height, right, or length of the cylinder that is extended through. The volume of any of these objects is the area of that base, that area of that basic shape that it started with, okay, times that height dimension, okay? And that's all there is to it. It's as easy as that. So, for example, this rectangle would be length times width. So the volume, sorry, we'll go through each shape. So area of the circle, it would be pi r squared. Area of a triangle is 1/2 base times height, right? Pretty easy stuff. The volume, we need to remember that this h is different than that h. We might relabel it as length, okay? They're just different. That's the important thing, okay? The height for the triangle would be this height along here, right? And the base would be down along the bottom. Okay, so once we get the area for those shapes, all we do is multiply it by that length, the height of the prism. We call it height because it's perpendicular to that base. One way to think about it is if you stood up the prism or the cylinder on that end, then this would be the height. That would be how tall it would be, right? So the volume of the rectangular prism is length times width times height, right? Which is, a perfectly good way to think about it, but you can, it's really perfectly acceptable to just think about it as area times the height, right? The volume of the cylinder would be pi r squared times height, right? And the volume of the triangular prism, which in my class right now, we're not going to have any problems on this, but just for fun, 1/2 times base times height times length. And again, you have to remember that these are kind of both height in one way or another, but bit of fun there. And that's really it. That's all you have to do. In fact, another thing to sort of think about is you could take a funky shape, just a totally random shape like this sort of squiggly line, extend it through space to create a prism, right? And the volume would literally just be area of that shape, if you could find it, right? This one might be a little tricky. You could maybe estimate it by sort of drawing some squares in there and finding it or something like that. And if you had the height, okay, all you do is multiply the area times the height and you get the volume of that cylinder. So, that wouldn't be a cylinder. This would be some sort of funky prism or whatever, but that's all there is to it. These are your more common ones, and for my class, we'll mostly be looking at rectangular prisms and cylinders. Okay, so pretty easy stuff. But good luck. See you next time.